Welcome to One and All. Myself, Dr. V. Sharan Raj. Today we are going to see the topic on volumetric shrinkage. It is a unit 1, metal crystal structure and metallurgy of welded joints. What do you mean by volumetric shrinkage? It can be known as metal shrinkage. It is also known as contraction. So what is volumetric shrinkage means? It is a contraction that occurs due to the change in state of metal from liquid to solid. The metal form will change. The metal form will change from liquid to solid. So, in this, contraction is divided into three stages based on the temperature range. So, in the last class, we said what are the three different types of solidification process. We saw three different stages. Just like that, the solidification stages continuation itself is a volumetric shrinkage. The solidification process occurs due to shrinkage of volume. The first stage is liquid contraction. In this stage, the liquid is going to contract. Second one is semi-liquid contraction. Third stage is solid contraction. So you know that in a liquid contraction, the form of metal will be in terms of liquid. So it will be in red hot condition. So there, due to the cooling effect during the solidification process, due to cooling effect, the contraction in a metal takes place. Next is in semi-liquid contraction. So here it will be at an intermediate stage. Certain portion will be solid and certain portion will be liquid, and here the contraction occurs at this stage is known as semi-liquid contraction. The last is solid contraction. Once the solidification is complete, during that time, so the contraction what we get is known as solid contraction. So in simple words, if I want to say what does contraction means, there is a reduction in volume. ಈ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಶೇಪು ಮತ್ತು ಸೈಜ್ ಆ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ, ಕಮ್ಮಿ ಆಗುತ್ತೆ. ದಿಸ್ ರಿಡಕ್ಷನ್ ಇನ್ ವಾಲ್ಯೂಮ್ ಈಸ್ ನೋನ್ ಆಸ್ contraction. Why this contraction occurs? Because there is a change in temperature. As the temperature reduces, so the contraction will also increase. During each stage, temperature changes or loss in a metal is a part of its original volume loss. At each stage ಏನಾಗುತ್ತೆ, temperature in changes losses happens in a metal is a part of its original volume loss. Original volume ಅದು ಏನಾಗ್ತೈತೆ, ಕಮ್ಮಿ ಆಗ್ತಾ ಇದೆ. The volumetric shrinkage begins in a liquid state as the metal cools to the semi-liquid state. ಅದೆಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಇಟ್ ರೀಚಸ್ ಅಪ್ ಟು ಸೆಮಿ-ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ತನಕ ಅದು ಬರುತ್ತೆ. ಅಟ್ ಲಾಸ್ಟ್ ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ಅಟ್ ಎ ಸಾಲಿಡ್ contraction. So here you can see it starts, the first point it starts from liquid, it comes back to semi-solid, then it reaches to solid. So you can see here there is a reduction in temperature, increase in time, reduction in temperature, increase in time. So this is what is volumetric shrinkage. Let us see next is very important, iron carbon equilibrium diagram. What is this iron carbon equilibrium diagram? So it shows the percentage of carbon in iron. So you know that it shows the percentage of carbon in iron. So how much percentage of carbon is there in iron will be easily visible in this particular equilibrium diagram. So in this sketch you can see there is a temperature. There is a temperature in degree Fahrenheit, and you can see in a bracket they are given degree centigrade. So this is a temperature scale. Next, what we have known as carbon. So carbon is basically, you can find this application in so what is the maximum percentage of carbon? Maximum percentage of carbon that can be added in iron carbon equilibrium diagram is 6.67 percentage. So here in this graph you can see the maximum percentage of carbon is 6.67 percentage. So in this case you can see, and remaining 93.2423 percentage will be what? Iron. What happens if 6.67 percentage of carbon, more than 6.67 percentage of carbon is added to the iron? So it will not dissolve. The maximum solubility is 6.67%. That is why it is 6.67%. If you add further, it will not dissolve. What happens? If you add a sugar to the water, it will dissolve. If you going on adding the sugar, what happens? At certain stage, it becomes stable and it will not dissolve. The sugar will settle at the bottom. Similarly, in this case, carbon, more than any 6.67 percentage of carbon if you add, so this extra carbon which is undissolved will come on the top of it, whereas the sugar will go at the bottom, whereas the carbon will come at the top. Why? Because it is a light. It is a light in weight material compared to iron. So the density is less compared to that of iron. That is why it will float. So this is the type of things. So what I am going to explain in this is that, what you are able to identify in this is that up to 2% of carbon mixture, it will be called as a steels. Up to 2% of carbon, it is called as a steel. More than 2%, up to 6.67%, it is known as a cast iron. So what is cast iron? Iron which can be casted easily are known as cast iron. Okay, in that, red cast iron, white cast iron, malleable cast iron, green cast iron, and different types of cast iron. What are those? What is this color? When the cast iron breaks, the fracture surface will be green. That is green cast iron. If it is a red cast iron, the fracture surface will be red. So based on the color identification, so they will identify the cast iron. So coming to this, in these steels there are two classification. One is hypoeutectic, next is hypereutectic. Hypoeutectic means less than 0.8 percentage of carbon, up to 1 less than 0.8% of carbon, more than 0.8 to 2, it is called as hypereutectic, hypereutectoid. When you come to this, in a cast iron also there are two types. One is hypoeutectic, next is hypereutectic. Hypoeutectic means it is more than 2, less than 4.3. Cast iron more than 4.3, less than 6.67, it is called hypereutectic. Coming to this, so in this graph, in this chart diagram, you can see that there are three different phases. Can you see? There are three different. The topmost is liquid. Next is, what is liquidus solidus. The bottom is solidus. The bottom is solidus. You say you heat initially. What happens? The metal will be, solid metal will be in ferrite plus cementite stage. It is the solid metal should be in ferrite and cementite stage. At this stage the metal will be in solid form. You heat it. How much do you heat? You heat up to the 723 degrees centigrade. What is this 723 degrees centigrade? It is called recrystallization temperature. What is recrystallization temperature? It is the temperature at which new grain growth takes place. Means dendrites. The dendrites are going to form at this point. So after that, what happens? The grain growth takes place and the crystal structure changes. So until that, the metal will be crystalline in nature. Crystalline means all the atoms are arranged periodically in a regular pattern. It may be a square, rectangle, hexagon, different shapes you are going to get. So in this above 723 degrees centigrade, if you heat the metal starts converting from solid to liquid. So once you go on heating, it starts converting to liquid, At this stage, this stage, the phase transformation will be austenite plus cementite. The cementite remains same, whereas a ferrite is going to change to austenite. On further reading, you can see here it is going to form a liquid. It is going to form a liquid. There are different types of very important technical terms are there. There is something called pier light. What is this point pier light? It is a point at which the solid metal is converted into semi-liquid state. There is something called ledubberite. It is a point at which the semi-liquid stage is converted to liquid. These are the two important points. Pearlite and ledubberite are the two important points where the phase transformation occurs. If you measure at that point, it will be converted from one phase to another phase. And when you see the liquid phase, so here it will be liquid plus austenite, liquid plus cementite is going to separate in these things. And you can see there is a graph. So here you can see 723 degree is very important. It is the recrystallization temperature. What is this 1130 degree centigrade? 1130 degree centigrade, it is almost equal to the melting point of any iron carbide diagram. Iron carbide material melting point is almost that. At above melting point, it will convert into liquid. So you can see the temperature, the maximum iron carbon equilibrium diagram. Any iron generally 1400 to 1500 degrees centigrade it can withstand. So I hope you understand these are the different types of things. So the solid stage is ferrite plus cementite, liquid state is this, so it is a semi-solid state. So let us see what is this. So iron carbon phase diagram is shown in a figure in this sketch. You can see iron carbide equilibrium diagram. The iron carbide phase diagram describes the iron carbon system which allows containing up to 6.67, that I explained, 6.67% of carbon. Maximum is 6.67, and the phase composition and their transformation occurs in a alloy during heating or cooling. From liquid to solid, cooling. From solid to liquid, heating process. It may be heating or cooling. Next, the maximum carbon content, how much it is? 6.67%. Then in the fixed composition of iron carbide, Fe3C. The following are the phases involved in transformation with iron carbon alloy. What are those phases? L. What is L? L is a name indicates liquid solution of carbon in iron. It is a liquid solution of carbon in iron. Okay, so you saw what is austenite and cementite. In this phase, you can see here, there is something called austenite. This is cementite. So these are the liquid phases. L stands for liquid cementite and liquid austenite. What is the delta? Delta means solid solution of carbon in iron. Solid solution of carbon in iron. Magnesium percentage of carbon in alpha ferrite is BCC. So this is going to form, this is an alpha stage, this is an alpha delta stage which is a combination of alpha. Next is known as austenite interstitial solid solution of carbon is gamma iron. So the center is gamma, this is L, whereas this is L, this is delta, this is solid, this is liquid, this is gamma. What is this gamma? Gamma iron means austenite FCC crystal structure with high solubility of carbon up to 2.06% at 1130 degrees centigrade. So this stage, at this point, you are going to get a cast iron, whereas at this point you are going to get a steels. Okay, so in that you will get low carbon steel, medium carbon steel, and high carbon steels are there. So next we can see austenite does not exist below 723 and maximum carbon is 0.83. What is this? Austenite, the austenite whatever it is there, this austenite phase, this austenite will never exist below 723. It exists about 723. What does it mean? This phase will never exist below this 723 degrees centigrade. Why 723 we have taken? It is a recrystallization temperature. That is the initiation of a grain growth, just like a trunks and leaves of a trees. Alpha ferrite is a solid solution of delta iron. Delta ferrite has BCC. As I said, this is a BCC structure. This is a FCC structure. Above this is FCC structure. When you heat, it converts from BCC to FCC. When you cool, FCC to BCC. So, crystal structures and low solubility of carbon up to 0.25 to 723 degrees centigrade. The carbon is maximum, low solubility is 0.25 percentage of carbon. It is not 0, it is 0.25%. It is 0, but here the point will be 0.25% of 0.25 percentage of carbon will be at this point. Next, cementite iron carbide, intermetallic components having a fixed composition of Fe3C. The main purpose of iron carbon equilibrium diagram is to form Fe3C, iron carbide. Cementite is hard and brittle. Why cementite is hard and brittle here? Because it is a cast iron. What is the difference between steel and cast iron? Steel has a very good ductility property. It can be drawn into thin wires. It has a good malleability property. It can be drawn into thin sheets. Whereas the percentage of carbon increases above 2.1, it will be very hard, rigid. It is rigid. That is why this cast iron is being used in lathe beds. It may be lathe, drilling, milling, shaper. All the beds are made up of cast iron, not by mild steel, not by any mild steels or steel materials. It will be made up of cast iron. But one of the disadvantages of cast iron is brittle in nature. Brittle means it will break just like a glass. When you apply more than the recommended load, what happens? The cast iron will break. The fracture surface is green, then it is a green cast iron. If the fracture surface is a red, then it is a red cast iron. So, advantages of cast iron means it can be casted easily. Any complicated shapes can be casted easily in this case, and it has a very good lubrication property. That is why it is used in beds, lathe beds, and good finishing operation. Easily machining operations can be done on this, on those things material. So as I said, cementite is hardened brittle. So these alloy steel containing 2.06 to 6.67 are known as cast iron. Any alloys steel containing 2.06 to 6.67 is cast iron. Any alloys containing up to 2.06 percentage, we will call it as steels. In all iron carbon alloys, mild steel and cast iron, the phase transformation from BCC to FCC occurs at 723 degree. Why they have taken 723? Because any metal, especially if you take steels or cast iron, the phase transformation occurs only above the recrystallization temperature, that is 723 degree centigrade. So let us see the MCQ. So multiple choice question. First one, contraction occurs during the change in state of metal form liquid to solid is known as what? What is that called? Whether it is a metal shrinkage, expansion, enthalpy or entropy. It is metal shrinkage. It is known as metal shrinkage. Contraction is divided into dash stages. How many stages it is being in first class thermodynamics learning? There are 3 stages. One is solid, liquidus and liquid. These are the 3 stages. So its answer is B. 3. So an iron carbon phase diagram describes percentage of dash in iron. So the name indicates in our iron carbide diagram, iron is there. What is the remaining here? That is a carbon. It's not copper, it's not nickel, it's not chromium. It is the percentage of carbon in iron. The diagram describes percentage of carbon in iron. The maximum percentage of carbon in iron carbon equilibrium diagram, how much it is? It is What? It is A 2%, B 3%, C 5%, and 6.67. How much percentage maximum it is? 6.67. What happens if you add more? It is not soluble and it will come at the top. Why it comes at the top? Because it is light in weight compared to iron. So it comes at the top. The face L represents dash carbon in iron. What is this face called? So this face is L stands for liquid or liquidus. So the face ferrite represents dash carbon in iron. It is a solid carbon. Liquid is L, semi-liquid is gamma. So this is what is known as solid phase. Maximum percentage of carbon in iron. Okay, so maximum percentage of carbon in iron is what? 6.67%. So the faces L represents dash in liquid. It is a liquid. The phase ferrite in a carbon dash carbon in iron is a solid. Last is at what temperature at which the phase transformation from BCC to FCC occurs. What is the temperature at which? At what temperature at which the phase transformation occurs? It is 723 because it is known as recrystallization temperature. So dear students, so here the unit 1 is going to be ended. So let's meet in the next class with unit 2. Thank you so much.